So in our last video, we were trying to prove that the intersection n equals 1 to infinity of 0, 1 plus 1 over n equals 0 to 1. And remember, to show two sets are equal, I have to show two parts of the proof. There are two parts to it. And in the last video, we only did one part. So what is left for us to do? Well, we need to show that the interval from 0 to 1 is contained in the intersection 0 . Okay, so let's outline the start of our proof now. What would the start of our proof be? I'm going to let x be in this interval 0 to 1. And then what conclusion do I need to get to? Well, I need x to be in this intersection here. So that's going to be the end of our proof. The end is going to be that x is in this intersection. What does it mean to be in this intersection? It means that it needs to be in every single set. So we'll use the universal quantifier for all n and z plus. In the positive integers, x needs to be in the interval 0 to 1 plus 1 over n. And then what does it mean to be in this interval? It means for all n and z plus, x needs to be bigger than 0 and x needs to be less than 1 plus 1 over n. So maybe I'll just say for all n, x needs to be bigger than 0 and it needs to be less than 1 plus 1 over n. So let's go back to our start here. If we're in this interval from 0 to 1, that means x needs to be bigger than 0 and x needs to be less than or equal to 1. Well, if you look, we've already got one of the things we needed for our conclusion. At the end, I needed x is greater than 0, and I've already got that. So I'm good to go. There's nothing for me to do for that part. But I still need this other part right here. So we're going to think about n, right? N is always at least 1, right? N represents a natural number, so n is greater than or equal to 1 for all n and z plus. And again, it's positive, so I can divide by n and get 1 is greater than or equal to 1 over n, and it doesn't flip my inequality. And 1 over n is positive, so that's bigger than 0. So in particular, 1 is going to be less than 1 plus 1 over n, because 1 over n is positive. And what do we have? We have that x is less than or equal to 1, but 1 is less than 1 plus 1 over n. So if you put these two pieces together, you would get that x is less than 1 plus 1 over n, and this was for all n and z plus, which is exactly what I needed to get to. So if you see right here, it's exactly what I needed. So we've finally kind of sketched this last part out, and you can write this proof formally, and we will have completed the proof that these two sets are equal to each other.